Good afternoon, Rich Nass, Executive Vice President with Open Systems Media, and I am here for this week's installment of 5 Minutes With. This week I have the extreme pleasure of speaking to Alex Lidow, who is now the CEO and the co-founder of Efficient Power Conversion. You may remember Alex, like I do, when he was at the helm of International Rectifier. Good afternoon, Alex. How are you?
Hey, it's good to talk to you again.
Same here, same here. It's been a while, and so let's get right into this because we only have 5 minutes. So I have to be honest, I don't know that much about efficient power conversion. I do remember a lot about International Rectifier, and International Rectifier was a fairly large company, and I'm assuming that efficient power conversion is not. So first off the bat, what's the difference between having lots of staff and having to do a lot of stuff yourself?
So, I think that the difference is the speed with which you can make change. As you get into bigger and bigger organizations, there are more and more people that are involved in any kind of a change, positive or negative. With EPC, we now have a little over 40 people. Most of them are PhDs, and we can invent things with extreme speed. We can address market niches and even broader markets with extreme speed and precision.
Okay, that's a very fair point. Okay, so I'm assuming that you need that. You need those traits in the new company. You guys are into Gallium-Nitride, which a lot of people don't understand, and I'll be the first one to raise my hand. I'm certainly not an expert in that, and there aren't that many people who are an expert in that. But I do know that it's been around for a while. So what makes you think you can be successful with this technology when others haven't been that successful?
So it's only been in the last few years that researchers were able to figure out how to grow gallium nitride as a very thin layer on top of silicon. And that was a real breakthrough because what it means is the cost of growing gallium nitride of maybe 2 microns thick is not very much. And being on a standard piece of silicon means you can build these products in standard silicon factories, and there are plenty of those around. So when we launched our company, we didn't have to build a special factory for our products. We actually just have machines to grow the very thin layer, and then we process it right next to CMOS wafers in a standard foundry. That really lowered the cost, but also made it much faster to get into the market.
Okay, so let's be kind of clear about that. What retrofit do you have to do in the factory to be able to use this technology?
We have none. We grow a thin layer of gallium nitride on top of a piece of silicon, and then we put it into the standard foundry, and it goes through very standard process steps right next to silicon wafers. It's amazing. And gallium nitride can be 6,000 times higher performance than silicon. We're already harvesting about 10 to 20x higher performance, and we're at lower cost.
So tell me what applications you see that this is going into right away.
So when we first widely introduced our products 7 years ago, the early adopters were those that needed the speed of gallium nitride. Our very first devices were 100 times faster than silicon, so new applications started coming out of the woodwork that needed the speed. A good example of it is LiDAR, that's light detection and ranging, which is used on all the autonomous vehicles, all the mapping vehicles, and all of them use our GaN transistors and integrated circuits. Another good example is wireless power. The newer generation of resonant magnetic runs at 6.78 megahertz, and that's a little bit too fast for silicon, but it's perfect for our GaN devices. So we're seeing as that market takes off, that's also another big market. And then finally, the mature industries like server power supplies and computer power supplies are they're more conservative in their adoption. But as we crossed over the pricing of power MOSFETs, we're now pricing in volume cheaper than power MOSFETs. They're starting to accelerate their adoption as well.
So you mentioned LiDAR. I know that that's a technology that's moving into the automotive space, and it has the potential to be really high volumes. Are you investigating that?
Absolutely. Every LiDAR system on every autonomous car today uses many, many of our eGaN transistors and integrated circuits. It is the technology that allows for the resolution of LiDAR that is needed for autonomous vehicles of all kind, including drones and underwater vehicles. So that's a fairly large market for us already.
So let me go back to my original question. Why haven't others been able to do what you guys are doing?
Well, there are about a dozen companies that are making GaN on silicon devices. So it's not that nobody else did it. However, you know, I think the background of my background, being, you know, one of the early inventors of power MOSFETs in the power management world, means that I have extreme experience in this marketplace, and I also have experience in this technology for many, many years. So I've been able to look at this market and say what really we need to do is not just make a higher performance device, but make it cheaper than silicon. And we are the only one of the GaN on silicon producers that really believes that and has achieved it. All the others are going for very high performance, high priced markets.
Now, are they doing that because they can? And I'm talking about where they're pricing it. Or is it because they have to, because they haven't figured out the manufacturing part?
Well, I think it's probably because they can, but if you can, then you may not try to figure out the manufacturing part. For example, this packageless technology that we developed is not trivial, but because of it, we don't need a package around our device, yet we can pass all environmental tests. That means that we save more than half the cost, because in a typical power device, packaging is more than half the cost. Nobody else does that yet, but they all will.
So what I'm starting to get from this is that you're just smarter than everybody else.
Not smarter, but I do have a unique experience. I built a billion transistors every 6 weeks when I was CEO of International Rectifier. So I understand volume, I understand cost, and I understand power management probably better than almost anybody else in the industry. And I'm applying that to gallium nitride because I know it will be able to kill silicon in power management.
Okay. I think I'm going to stick with you might be smarter than everybody else.
Well, I don't know. Time will tell.
Very good. I'm afraid we've used up our 5 minutes, and that was extremely entertaining and interesting, and I'm sure lots of people will be looking for more information on the technology. That was Alex Lidow. He is the CEO and the co-founder of Efficient Power Conversion, and I'm Rich Nass with Open Systems Media. Have a great day, and thanks, Alex.
Thank you.